Welcome to the webinar on using analysis and optimization for Infraworks. We'll give it a minute or two just to allow some others to join. Just to let you know, there is a time delay with the broadcast, so just be aware that there's no live interaction. There's a chat box that you can use to communicate. Should you wish. As an introduction, or just keep the conversation going, we're going to be looking at some of the optimization that's available for us within Infraworks. I've recently had the opportunity to get to know Infraworks a bit. It's not a widely used platform within South Africa, although I think it should be. It's a great tool for conceptualizing infrastructure design, roads, railways, bridges, sidewalks, watersheds, and it's a conceptual tool, but it's a very good way to start a project off. And of course, it communicates with Civil 3D. So if you do have an Infraworks model, you can do your conceptual design on there, and then later on you can read that database with the Civil 3D. And you've also got access to GIS databases. So if you have ArcGIS or something like that, then you can gain access to those models via ArcGIS. That's quite a common thing within South Africa. After a civil infrastructure project has been completed, it will be converted to GIS and uploaded onto the provincial, municipal, national databases so that that's available for somebody else in the future. So you can get hold of some very accurate data. In this case, we're just going to leverage off a prepared file that we typically use in training. It's from the Ascent handbook, but it does have the preparations for the file to demonstrate correctly. Unfortunately, I have not yet progressed on an actual project to such an extent that we can demonstrate that live, but hopefully in the future that will be possible. I'll definitely be looking at infrastructure going into the future. Right, so I think we've got everybody that's going to join would probably have joined. If somebody else joins later, remember there is the chat box that you can communicate with me. Even though we are not live and we can't take live questions from you, we will be keeping a look on the chat box and field your questions as they come up. Right, so the things that we're having a look at today is the alignment optimization, the profile optimization, a bit of traffic simulation, and then also watershed simulation. It's the main ones that people seem to be interested in. If you don't know what an alignment is, it's the XY orientation of a road. The profile is the Z. On traffic, you'll often see people standing on the corners with clipboards measuring the number of cars that might approach an intersection. It's the similar approach in Infraworks. If we know what the demand of the road will be and we look at our design, then is that sufficient to carry the current load and maybe the projected load? If there is going to be development in the area, then you can make a good guesstimation as to what's going to be expected in the future. And then also with the watershed, just to figure out exactly where we would like or where the water will drain to. Of course, to do that accurately, you'd have to have a big enough area, and that's one of the things to take into consideration. Right, so just note there that the initial design can be done within Infraworks. General idea about what you want to give to the client in terms of what you want to develop, and then once that's accepted, you can take that into Civil 3D. With the corridor optimization, you should note the following, that it is processed in the cloud, so it's not processed on your computer. And depending on the size of the optimization or the size of the simulation, it might require tokens. That's the old cloud credits that we used to refer to, and that you have to purchase separately from the license cost to run these simulations if they're large. And what we'd like to do is to calculate the shortest alignment and the best profile, taking the cost of the roads, crossings and bridges and watering crossings into consideration. We'd like to make a considered, we'd like the simulation to take a considered approach with giving us the solution. You can also use various settings to generate different options and then import the generated roads into the option and compare between the options. You can do that via the report dialog. And then there's some inputs that you can give into that simulation. So to look at how that operates, we've got Civil 3D that's open here, and the purpose of this exercise would be to design a new road that's traveling from somewhere over here and then hooking up to a road that's on the coastal area there. So we'll just switch on that option. You'll see a road has been designed on the coastal area over there, and we would like to have a road that that travels from here to there and gives us the best solution. The analysis tools that you'll have available to you, you'll find that on the Analyze tab. We've got our transportation, which includes profile optimization and corridor optimization. We're first going to have a look at corridor, then profile, and then after that some traffic. But there's also site distance. You can see the job monitor, that is a feedback mechanism on how the job is going. You've got a mobility simulation as well, and that can be applied to pedestrians. So if you are designing a new airport, then you might even design a airport passport control. That might be something that you might consider. So it's quite versatile. The structural analysis we won't be looking at today, but you can analyze a bridge, the girders that you choose, to see if that will carry the load, and then under the drainage as well, we've got watersheds that we'll have a look at, and then we'll also have highlighted drainage, the size of the drainage network, and you can inspect the performance, and then also the rainfall content. So you can see that you can assign and manage model-specific rainfall data for more accurate drainage design. So if you have local content or local measurements, historic measurements for your area, then you can calculate the rainfall there. So there's quite a lot. We won't get to everything, but it's just a quick overview of everything that is available within Infraworks. So let's have a look at the jump right in and have a look at the corridor optimization. You'll see that it opens a tab on the right hand side, corridor optimization. Whatever settings you apply here, that will apply to the path that you are creating. You can manage your paths here as well. So if you don't want to have this path, you can delete that path, like so. And then we'll have our, first of all, how fast are people going to drive on this road? We're going to make that quite a slow road, say 40. So with everybody walking their pets to the beach, we'd like people to drive carefully. And then we'd have the road construction. So what type of component assembly do we want to use? There are various ones that you can use here. We are just going to use the 2 lanes, so just a normal road. And in the bridge design, that's constant, and then also with the tunnel. So you'd have to set those up beforehand. There you can see bridges and decks and interstates and whatever. But in our case, we're just really interested in this road. Then on the path itself, you've got none at the moment. We've deleted the one that was there before, and you can then add a path. When you say add a path, you'll find that you're expected to click on some points, and you can use the left click button to say that you might want to get this road going from, say, this road over there, so somewhere over here. There's your first point, and then you can see warning the PIs are too close until you move further. If you move further out, you'll see that warning disappears, and there we'd like to go all the way onto this bridge or onto that road there. That then places a sort of a box around everything. That's where you can see these markers there. They don't like to go outside the surface. Now that's a straight line. We might want to put an L-shaped curve in there, so we could right click and say add PVI. That will insert a PVI, and we can then maybe state that we'd like to go straight across the river like that, and you can add more if you wish. But that's pretty much the road that we'd like to travel, and we've got advanced settings that we can choose. So on the advanced settings, we've got cost zones and suitability maps. So this area over here, if we zoom in, this is a hotel with some access roads and so on. So we definitely like, within the scope of the purple corners that we've got there, we'd like those to be excluded from that area. So we can draw an avoidance zone. You'll see that we can click on the plus sign there, and then again using left click, and again once more, when you want to finish this, you can double click to finish. That's then the avoidance zone, so that must definitely stay outside of that box. On the coverage, you can put down a hard cost if you want, and some more info there if you'd like. I'm going to just take avoidance zone 4. There. On the suitability maps, we can choose. Suitability maps are areas that you would input areas of interest. So what we do have here is water and buildings, where we are saying that there's a penalty cost, opportunity cost, should we take the road through a specific area. So it's a statistical input to the analysis. There's the settings for that. If we apply that, we can also include the current suitability map. If you had to take that off, then it wouldn't include it, but if you include it, it would include that there. We've got some construction rules which we can leave. We've got a grading limit, cut slope, what angle that comes in, so your daylighting, your alignment constraints, your minimum radius. Let's just make that 70, why not? We've got profile constraints, a maximum gradient of 8, and then some construction and earthwork costs if you want to include that. If you had to open that up, then that's basically the unit prices that you can input. It's in dollars, but in any case. So that basically sets up the analysis. So what we need to do next is now run the simulation for path 1. Just want to make sure if that ported, yes, it did. And then what we can do over here is click optimize it. that will run the optimization. That uploads the information onto the cloud and queues it up. So you'll see that it's got a status which just says it's in progress. So that will notify us later, also by email when that's done. So I've been put in a queue there for the calculation. Then we've got the report and the result, which we're waiting. That's the description. On the type it says that it's a corridor. There's an ID or a GUID, whatever you want to call it, that can track the simulation. Jacques, I see you saying that the sound is soft. Let me try and see if I can up that. Let me just see what I can do with the settings over here. Right, Jacques, I'm not sure if you can hear me at all, but let's try and see if we can up the microphone volume in some other way there. Those are all the speakers. Let me try and see, maybe if I close the TeamViewer application, that might go better. So I'll just let me know if the sound improves. I think I've not too sure what else I can do here to improve that for you. I do apologize. Okay, so I've upped the volume on the microphone. So hopefully that will behave better now. Alright, hopefully we've got the sound sorted out now. Let me know if that's better, Jacques.
Okay, so I've upped the volume.
There, that sounds better on my phone as well. So we should have success now. So it seems to be a window setting over and above what one typically expects. So my apologies there. Alright, so this is still running in the background there. It's probably going to run for a while. You can, of course, close this. And then you can also get back to it if you use your job monitor. So your job monitor will open your jobs that are processing in the background. So you don't have to stop working once you've given something up for analysis. And then of course you can do different paths. So that's the typical path that you'd like it to go. But you can also use different paths. And then you would just create another one. So we've got path 1 here. If we do path 2, then we can do the same thing. So we might say, well, we want it to go from a different beginning. We want it to hook up to the same sort of road here somewhere. And exactly the same way as we've done before, you can add PVIs. It's taken a little while, but we can add PVIs. So that might be path number 2. Again, we'll have our advanced settings where we choose our avoidance and the suitability. We can keep these things like they are. Profile constraints, that's all good. Okay, avoidance zone 4. And then we can just say which one we want to use there. 4 is on, yes. I don't need to draw another one. And then if I want to optimize that one as well as a different option, then I can say analyze 2 as well. And so I can create different settings for the optimization, different speeds, different radii, gradients for whatever is necessary. And it seems for some other reason this one was rejected. Corridor optimization 1, it says the waypoint was rejected. So let's just have a look at that. There's something to do with that. Let's make this a bit bigger. Right. Path number 1. That was aborted. Let's just optimize one again and see what that results as. Alright, and then we'll see what that comes out as. At any time, if you want to open the jobs, then you can have a look at the job monitor, and that will open the job monitors. Alright, so our first attempt over here, that was rejected due to some or other algorithmic internal error that we've experienced there. Let's see how that turns out. The other optimization that you can apply is a profile optimization. So this feature, okay, can select a road that we might want to optimize. I recognize that it's Morris Beach Boulevard. That's this road there. You can change the design speed. Again, we've got our structures that we can apply, as well as the advanced settings. We've got our maximum gradient and minimum PVI spacings. PVI frequency, and then we've also got anchored PVIs that we can choose. So if they're very close together like these two, it will probably generate an error because of the PVI spacings. You can't have those two close together. That's the if you click on them, then you can peg them so you can keep those points fixed if you want. I'm just going to keep the beginning and the end point fixed. And again, we've got our earthwork and construction, and option if you know as bridges or bridges and tunnels. And then again, when we've done that, we can say optimize it. And provided the analysis is not too large, it shouldn't cost us anything, but if the analysis is big, then that will take some time to process. So you can see the little icon over there. That's now analyzing a profile for us. And again, if we had to change one of these design criteria and we say optimize it, then it will run another optimization. So we'll just have to wait for those results to come through. Hopefully they come through quite soon. If they don't, I'll show you an example of what that report looks like. Right, so that's the alignment and the profile optimization tools. So this is now looking at this area over here in terms of traffic. First of all, note that whoever modeled this model that put static cars down here, those are not part of the traffic simulation. They're just models that were placed there. So they're not going to play any role in our traffic simulation. We're going to include a T-junction that you can see at the top, a T-junction at the bottom over there, and a crossing below here. Let's get that going. Here's the traffic simulation. The boundary that we'd like to choose, again, it's left click until you're done and then double click. So we might say that this area over here is of interest for us. Let's cut it off before this intersection there. Let's include a little bit of this road just in case we've got traffic jams that we want to include. Something like that. Right. If you do have any roads that are not component roads, it will give you an error, and in that case you would need to change them into component roads. Now this is now traffic study 1. We can do that per lane, and then we can do a quick simulation, and then we can run that simulation. Right, and there we've got the animation player. If we zoom in closer to the action and see if we can see some cars coming through, I've got the speed. If you set the speed to 1, you'll see it's very slow. You might see a car coming through every now and then, depending on how it's set up. Times 30. There we can see some of the cars zooming along there. So this might be nice enough just to simulate cars driving through there, but we've got a lot more that we can do. and we can set that within the traffic settings. Okay, so I've got in the background here, which I just opened something that I've done before, a corridor optimization versus a profile optimization. So let me open that for you, then you can have a look and see what that is like. So once it's done the corridor optimization, you'll see what it looks like here. We've got the final path that was chosen, final alignment, the starting alignment. You can see it optimized it all the way through there. It's put a curve in down to the finish point. It shows you your points of intersection, your avoidance zone, and then it also shows you a profile that it might have generated there. Other information that you get out of it is what sort of alignment information you got. This is in feet, design speed, swathe. You can see there's a lot of information that's coming out of there. It's a very simple construction, this road. There's a mass diagram. Creates a type of a hauling schedule. And then on the cross sections, it shows you the type of thing that you can expect on cross sections. And then going through to a cumulative cut and fill volume report. So obviously I'm not a structural engineer or a roads engineer, but this might make more sense to you than it does to me. The information that's coming out of here, that might be relevant to what you are doing within your profession. This is the alignment or corridor optimization report, what we know as an alignment. And then you can compare that to the profile optimization report, where it's not taking an existing road, which you can see the road profile as it exists at the moment. And then we've got the optimization coming through there. The same type of information as what we'd expect from the corridor or the alignment optimization. It's actually a corridor optimization, but you can also optimize an existing road. Again, there's a mass diagram, haulage, and cross sections as you go through that. Right, so that will be available to you once the simulations have been done. I've just taken the liberty of showing you what they look like if you generate them before the time. Okay, so just returning to our traffic simulation, if you right click on the traffic simulation, then you can boundary, then you can see that you can obviously add and remove vertexes or create a new traffic study area, but there's also this thing over here that says traffic analyst panel. Now it says the traffic analyst panel provides access to advanced parameters, enables multiple simulation variants. Do you want to edit this using tap? I say yes. And this now opens the traffic analyst panel. Just as an aside, note that the default installation for Infraworks is not sufficient to run a traffic simulation. You will also need to install some Java API. They do give you different options here that you can download. What is important is I've tried them all. I found the one that works best is the Amazon Corridor 8, and you can get that from Amazon website, Corridor. It takes you to a website like this. You've got different versions available now. I mean, typically one would want to have the latest version, but in this case, go to Corridor 8. You'll find the downloads available. In my case, I'm running Windows 64. So the Microsoft installer, the MSI, that worked best. You can just install that, download it, and install it. And once you've done that, that will enable the traffic simulation in Infraworks to run. So there's a lot going on here that I don't understand because I'm not a I'm not a traffic specialist, but again, it might be within your understanding, not mine. So you'll see that you've got your simulation where you can run a simulation, you can press play. There's an analysis, there's some actions that you can, there's some layer and view. Alright, so all of those might play a role within your job. I don't understand them overly well. I don't work with them from a day-to-day perspective. The quick simulation that you can see there, short morning simulation, whatever it is that you require. But what you do have here are further commands at the top left. The control of the intersections and the demand on the roads. That is the two ones that we'll have a look at. And on the control, let's first have a look at the demand. Alright, so here we can see that we've got some demand items there. If you click on one, it will show you a point on the left hand side there. Then it points towards others. So the division 3, 2, 3 and 1. Clicking on 2. So 1 is obviously this road coming in here. Right. So how many cars would you like to come in from 1 going into the other divisions? Let's put 30. We'll just say that there's somebody coming in from there. Yeah. And if you click on each one of them, you can see how many are going to go in there. It also calculates the total. So this you would go by selecting having somebody stand there with a clipboard and figuring out what the demand is going to be. I'm just guessing values here. Okay, so there's the total demand per division. Then we can say okay. And then we can also have a look at the control on the intersections. The way that this works is if you click on, just make these a bit wider so we can see what we're doing. So it will also give us a visual. It always helps to click on things or headings within this. It will give us an indication of where it's looking when we click on that. So church into Redwood. This is where we can see how that's going to turn. So this is an American road. They travel in the right-hand lane. So obviously this guy is going to have to yield to cars coming from the front. So we'll make the assumption that on this main road traveling through here, this long main road that the mouse is traveling down, going north to south, that's going to be free flow. Okay, so we won't stop the cars there. So that might be a mistake because, you know, this guy's going to have to yield until he turns. All right, so this in that direction, that's free flow. There's a yield going from right to going out of there and onto the road. This is a one-way, obviously. Then that can be a stop sign is fine. Also stop sign. So this person has to stop. That we can make free flow and free flow. So I'm going to go through each intersection like that. I hope I'm not getting confused with the American. Okay, so there's a stop sign, also free flow, yield. Yeah. Alright, so we'll take that as being default, and then we've got pair. So that's up to you how you set it up, how you want to control that. And the simulation, of course, that will be dependent on how you set this up. So if you say okay, you have to run that simulation then. That will take the updates that you've applied there. And there we can see the cars that are traveling. So is there going to be a traffic jam there? Yes, there we can see in time how the traffic jam builds up there. And so we would have to tweak the simulation to make that better. On the north-south road, there's not much of a traffic jam. That's all free flow, obviously. So I would suggest that we put a stop sign on this road here and on that road there. So let's see how that improves the situation. Going on to the intersection control, looking at Redwood and Church. Instead of making this free flow, you can make that a stop sign or even a yield. And then Redwood to Redwood. Let's make that a yield as well. Let's see if that will improve the situation. Okay. Let's go back to the beginning and I'll run the simulation as it is at the moment. So the yield is not making much of a difference. Let's change it into a stop. Redwood to redwood. Stop. Redwood to redwood. Full stop. Apply. Okay. Analysis run. Right, so there we can see this now alleviates the traffic jam that we've got at the left hand side, and traffic is building up at the top. And so perhaps this, yeah, that's getting a bit heavy as well. So maybe we need 2 lanes. We'd have to go and have a look at that situation. But it's very good that one can check the design of the road, if it's 1 lane or 2 lanes or whatever it is. And that you can do through the control of the intersections. So I'm going to make one of these. Biggest traffic jam seems to be in this direction over there. Yeah, it's not like one would like to have it. One would have to see about the design of that road. But, you know, it's guesstimates that we've used to start with anyway. We've also got this ability to signalize something. So if we look at this over there, then we can say, how must this be behaving? Must somebody going in this direction, must they only be able to turn left or right or both ways? Then one can set that as well and say, well, with this Redwood North Road, the only thing you can do, say, is turn left. And then one can set that up, refresh that. Let's see how that goes. One can also click on signalize, which will put a signal there. And then run the simulation again. I see the first car turned right. There is a double lane there, but mostly it's turning left. Alright, so that's the traffic simulation. Just a general overview for you. I'm sure that if you understand this, then it will make more sense than you usually find within any company, that there is a person that is a specialist at traffic design, and they are usually the ones that use this traffic simulation. But certainly something to look at if you want to design infrastructure, existing or new, or if you want to modify existing infrastructure. Okay, so I'm going to have a look and see what happened to the job monitor. So again, it hasn't processed yet. I know from experience that this might take a while. That's why I showed you the reports earlier. This one, of course, was rejected. Others haven't been rejected yet, so that's maybe pointing towards a positive outcome. To exit this traffic simulation, you can press escape. The last thing that we're going to have a look at is drainage. So we'd like to know how the drainage is going to work for this area over here. So that's the or the watershed rather. Again, it leverages cloud computing. And the grid spacing. So from experience, I know that this will probably fail if we use these existing values. Let's just see how it fails. So you can either pick a point or a road. If you click a road, you can say, right, between here and there, let's have a look what happens. Press enter. That then runs the watershed analysis. We can say it failed. There's a bit of help there if you want to know about the watershed analysis. I know from having prepared this webinar that we're going to have to change the settings. I'm going to put the grid spacing all the way down, as well as the stream threshold. Accept that. Again, click on that road. Take that through there. Press enter to run the simulation. And now it's able to generate the results. You can see it's obviously truncated the watershed on the boundary. So it might be prudent to increase the size of the model to include more of the topography so we can see what a proper watershed is going to look like there. And then, as they've done here, to design a culvert to manage the runoff from the watershed. So you can then design your culverts underneath your road. And it pinpoints that to tell you exactly where that is. Okay, so that's the watershed analysis. It just helps you during the design of the infrastructure to make sure that you've got the types of elements, bridges, culverts, tunnels, whatever you need to typically design your concept. And then once this is all done, then to push that through to Civil 3D. I don't know if, basically at the end of the webinar, I don't know if we're going to get an opportunity to see the results from the job monitor, unfortunately. But I just want to highlight something here where you get the report and the result. The report is just going to give you access to that PDF that I showed you, and then the result is going to create the possibility for you to have Infraworks create an option for that design. So you can have multiple profiles, multiple corridor designs, and then you can put them into an option, which you can then visualize. So an option is one of these guys at the top there. You can put them into an option so that you can visualize that and show a client maybe 2 or 3 different designs and say, well, for this one, this is the report for that, so this is the sort of costs that we're expecting, or the amount of work, versus another one, and so you would go through the different designs to see what you can do. Just the last note before we conclude this webinar, the other options that are available to you, just take note that you can also do site and mobility simulations on the traffic side, and that you can analyze structures like these girders that you see on the bridge there, that you can do that analysis if that's big enough to carry the load. And then also on the drainage, you've got some of that information that's available to you. So with that, I'll maybe just conclude with the slideshow. If you need to contact us, we'll find our contact details, and it's corridor optimization, the traffic. Remember the Java, it's not difficult to install it, you just need to know which one to use. The Watershed, and then if you have any questions as well, you're welcome to either type them into the live chat, or you can see that we've got our contact details above there. I'm at in the Cape Town office, but we've also got representatives in Johannesburg, Port Elizabeth, where our head offices are, and then Durban. I'll just wait to see if any messages are coming through, in the absence of which I'll just invite you to, especially if you have the AEC collection, have a look at Infraworks, and maybe try and see if you can use that to your advantage when you do an infrastructure design. If you want to learn Infraworks, there are obviously courses that you can attend, but there is also the help files. So I always say to everybody that I come into contact with, don't forget that you've got the help menu within most of the Autodesk software, going on to online help, and that typically is a very good resource which might tell you how to start, and then how to do your data exchanges, the basics, how to work with the models, and going all the way through into carriageway, civil structure, drainage, glossary, and so on. So this is a very good resource, but have a look at Infraworks. I know it's not widely adopted within South Africa so much as Civil 3D, but definitely a good beginning if you want to visualize and present a civil solution to a client. With that, I'll sign off and wish you a happy week further. And please let us know if you have any further questions.